All right, 3.6. We're going to take a look at analyzing arguments now with truth tables. There's also another component in this section that has forms of arguments. That part's pretty straightforward, but it can be a little confusing on the startup as well. All right, so we're going to look at the truth tables part first. So there's a fair bit of writing here at the beginning. This talks about how we decide if an argument is valid with a truth table. So the first thing that we have to do is we have to assign a letter to represent each component in the statement of the argument. All right, so like in our last example, we would have had the letter S representing people who drive, or the letter T representing people who make life a little worse. Okay, so the people, the categories, the statement pieces are represented as letters. After we do that, step 2 is to express each premise and conclusion symbolically. What does that mean? Well, it means we're going to join them with ands and ors and if-thens. So all those symbols that we've been working with, right? The V's and the upside down V's and the arrows, negations if negations are appropriate. We're going to create symbol statements in step 2. Step 3, we're going to put all the symbols in a row, right? The premise and this premise joined together necessarily create this conclusion. It usually ends up being a very, very long statement with symbols. And then step 4 is the truth table that we create to represent it all. So I'm going to pause. I know you guys have a lot of writing to do to write that down. All right, so part of what you wrote down in step 4, I didn't actually say it out loud, so let me mention it, describes how we decide if the argument from the truth table is valid or not. It tells you that if it is a tautology, it's valid. What's a tautology? Yeah, when the last column has T on everything. Okay, that was a previous lesson that you guys had. So we're looking to see at the very end of the truth table that we've created, this big giant truth table, if everything at the end says T. And if it does, we have a valid argument because we have a tautology. And if you think about what we did back in section 3.5 and described as valid versus invalid arguments, that kind of makes sense. What it means is that everything at the beginning happening forces the end to all be true. And that's what it means in order to have a valid argument. So everything at the beginning happening forces the end to be true. Okay, so let me take one more minute to finish up writing. I think still a couple of you are writing. Sorry about that. I know it's a lot. Okay, for those of you whose handwriting is small, you're in luck today. For those of you whose handwriting is large, you need to write as small as you can. So I'm going to show you just so you can see my notes. Do you see the bottom of the page? They're long. So you need to write small or you're going to run out of space. Okay? So I have to write small on my screen too, which is sometimes a struggle for me. You okay with that? All right. I see some faces, man. Some of you are concerned. All right, so the first one's not too bad. The second one is quite long, and the third one also is quite long. First one's not too bad. Good, Nathan? Yeah? Okay, it's all right. Okay, so we're starting out with something that just has a bunch of symbols, right? We're building up to being able to use language with it. So this statement already has a couple of the steps already done. So looking back at our steps, step 1's already done. I've already got my letters, P's and Q's and whatever. Step 2 is already done. It's already has the premises and the conclusions represented symbolically. So steps 1 and 2 are already done on this problem. Step 3 is where we join them all together in a massive statement. And let me show you how that works. We take the first premise, which is tilde P implies Q. And we join it together with the second premise and an and statement. And the second statement is just Q and Q. And then we make that the premise of an if-then statement.
Is it NP or NP?
Oh, I'm sorry. I just looked at it wrong. It's P. Thank you, Aaron. P. Yeah, so P from here. So sorry. Yep. And then we make that the premise of it's the whole thing joined together in brackets is the premise. So it's got an arrow next of the conclusion, which is tilde Q. Okay, it always works the same way. You join the first statement and the second statement with and, put it in big giant brackets, you do an arrow, and then you end with the final statement. In this case, it's tilde Q. Now, what does our truth table look like? Well, it needs to have all those components. That's why we worked with that back from section 3.1 all the way through 3.4. So we're going to work from the inside out, but we're going to first start with P's and Q's. And if you want to put all the tildes that are present next, you could do that too. So we need a column for P, we need a column for Q. All right, so we're going to have this big giant truth table. It's going to start out with column for P and a column for Q. And I actually don't usually put the tildes first. I just go in order of where they show up because things are then closer to where I need them to be. So what I tend to do is I tend to work from the inside out. So the first set of parentheses does have a tilde P in it. So my next column is going to be tilde P. And then inside that parentheses, now I have both pieces. I have the tilde P piece and I have the Q piece. So my next column is going to be tilde P. We'll fill all in the truth table last. Tilde P, arrow, Q. Right? That's the part that's in the first little bitty parentheses, right? The first one. The next thing that we're going to do is we're going to join that together with an and statement with P. So now I have everything in the brackets. Tilde P, arrow Q, and P. So I'm working from the inside out and I'm just building on pieces as I go. Does that make sense? Column headers are just doing that. They're building on the pieces as we go. Now I have everything in the brackets. All that's done. So I look at my conclusion. My conclusion is supposed to be just tilde Q, and I don't have a column for that yet. So this is the point where I would do my tilde Q column. Whoops, not quite long enough. And then the last statement right here is joining all of it together. So if you'd like to just take the entire statement and write it there, you can. What I do is I usually abbreviate. So this, we'll use yellow, so it was easier before. This is column 1 now, and this is column 2, and I want to join these two together because this is now 1, all of it over here, and this is now 2 over here, and I want it to be joined with 1, arrow, 2. If you want to write it all out, you can, but you probably are going to want to do some condensing when we get to further examples, so I just thought I'd show you this here. Are you okay with the column headers? The only variation that kind of is a reasonable thing to do in addition, if you don't like it this way, would have been to put the tilde Q column over here with tilde P, and that would be okay. I just like it at the end because I don't need it till the end. Okay, you know how the first two columns start. What's the P column? True, true, false, false. So we're going to fill in what we can do. True, true, false, false. Start with the easy stuff. What about the second column, the Q column? Good. True, false, true, false. All right. My third column, tilde P, takes everything in column P and reverses it. So what will column tilde P be? False, true, false, true. I'm sorry. I was not listening to you guys very well. False, false, true, true. I was doing my tilde Q column in my head. So sorry. Okay, all good? You guys are keeping me on my toes. Thank you so much. Appreciate it. All right, the next column takes more effort, right? And not only does it take more effort, but we have to go backwards in the way that it's set up in my table, which is a little confusing. So we're going to go from column tilde P, and we're going to go backward to column, draw the arrow the right place, column Q. So we're going to go from the yellow column to the orange column. Okay? So I know you guys watched a video, at least I hope you did, about this. I didn't actually say it in class with you, but you kind of felt like I did, I hope. When you're doing a truth statement or a truth table with an if-then statement, if it starts out true, here we go, one down here, and it ends true, it's true. So my third row is true, true, that's true. And in fact, that's a very nice one because it's true, true for an and statement, it's true, true for an or statement, and it's true, true for an if-then statement. So that one is almost a free, get it all the time kind of thing. The other time an if-then statement is true is if the premise starts out false. So anytime you start out false with an if-then statement, you have the ability for each of these things to to be true afterwards. So we say that the truth statement's true. So false implies true is true, and false implies false is also true. Truth tables for if-then statements are the messiest ones to sort of process. And then the only time an if-then statement is false is if it's true implies false. So that's my last column. True implies false would be, in fact, false. Is everybody all right with that? Okay, I'm going to erase my colors because I want to keep using highlighters as we go. And so I'm going to erase them as we need to. All right. The next column takes column that I just did, tilde P, arrow Q, and it joins it with the column that's P, which is at the beginning. I'll highlight them both in orange. This is an and statement. And when is an and statement true? Only if both are true, right? That's the only time. So looking at the first row, I have true, true, so that is true. And the second row is also true, true. So it's true. But row 3 and row 4 have falses in them. In fact, they start out false with the P itself. So rows 3 and 4, are false. Good? Next column's easy. You fill it in. What is the tilde Q column going to look like? Yep. False, true, false, true. Okay, everybody good? So this is kind of why I wanted my tilde Q column at the end, is because then my if-then statement I'm about to create is going to go from left to right, which is easier to look at, I think, than going from right to left like we had to just a moment ago. So now we're taking column 1, and we're doing an if-then statement to column 2. So from column 1 to column 2. The first one says true implies false. That's false. The second one says true implies true. True. And then the third and the fourth one both start out false, which means they're true. Good. So this is the entire truth table. I know it didn't have context to it, but the reality is at the very end, do I have a tautology? No. What does that mean? It's invalid. So when I get to the end, I make my decision based on the last column. So what is it about number 2 that's, let's first start with, what is it about number 2 that's easier than the one we just did? There's no tildes. That's good. What else is true about this one that makes it easier? It's already written out. I've already all the way to step 3. Do you see that? Right? I've already got this formed all this together. Those two things are very nice. What is it about number 2 that's harder?
3 letters.
There are 3 letters. All right, so take the good with the bad, right? We've got 3 letters. So 3 letters means I need 3 columns, and they always go in order, P, Q, R. Okay? So we're going to create a bigger truth table simply because I have 3 letters. So I have a P column, a Q column, and an R column. So P, Q, R. And much like I did on the last one, I'm going to put all my column headers in first. All right, so what would the next column most likely be? What seems reasonable? Yeah, the first set of parentheses, it's P arrow Q. What do you think you might want to do as your next column? Yeah, the other set of little parentheses, Q, arrow, R. Now what? Both of those together with the and that's between, right? So this is the point where I'm going to label this 1 and I'm going to label this 2. If you want to write it out, that's fine. And I'm going to call this 1 and 2. Because my column headers are going to take up lots of space very quickly. What do you think I might do next? P arrow R. Then what? Yes. Okay, so yeah, I'll label it 3. I'm going to label the 1 and 2 3. I'm going to label the P arrow R 4. And my last statement's going to be what? 3 arrow 4. It's going to be all of it. It's a big truth table. Do you understand the column headers? Okay, that's good. Once again, it's got 3 columns to it with the PQR. So what's P going to look like? Yeah, so it's going to have 4 truths. 1, 2, 3, and 4. And then it's going to have 4 falses. 1, 2, 3, and 4. What will column Q do? Yeah, so it'll alternate in pairs, right? True, true, false, false, true, true, false, false. And how about the R column? Yeah, it'll oscillate trues and falses all the way down. So true, false, true, false, true, false, true, false. Even if you can't figure out what to do next, please fill in those columns. Get partial credit, okay? Please fill in what you can. All right, we're going to do number 1. I'm going to do some highlighting like I did on the last ones. We'll use yellow this time. All right, so it says P arrow Q. So this is column P and this is column Q. So if-then statements are true when? When they start with false. Let's actually do those first because you mentioned it. So that's the last 4 rows, right? All the last 4 rows are automatically true because they start out false. When else is it true? When they're both true. So that's row 1 and row 2. Yeah. So true, true, false, false. Okay, all good? Okay. I'm going to erase my yellow. Actually, I'm not going to erase all of them. Erase that one. The next one, what I've labeled column 2, is Q arrow R. So Q is already highlighted. Here's R highlighted. It's an if-then statement again. So like you told me before, anything that starts out false is going to automatically be true. So I'm just going to do those first. The false, false here on row 3 and 4, and the false, false down here on row 7 and 8. So 3 and 4 are true, and 7 and 8 are true. What other ones are true? The first one, and yeah, row 5. So row 5 has the true, true right here in the middle. And so did row 1. The other 2 are the false, true pieces. I'm sorry, the true, false pieces, right? T and then F. So they are going to be false. All right, row 3, which combines rows 2 and row 1 with an and statement. And when is an and statement true? When they're both true. Wonderful. So let's go down the row, or down the column together. What will it start out with?
True.
True. And then?
False.
And then? Okay. I just wrote what you told me. Does that look good, everybody? Excellent. Looks good to me too. All right, well done. All right, row 4, or column 4. Column 4 says we're going to do P implies R. So here's P and here's R. If then again, right? The last 4 are all true. I agree. What else is true? 1 is true.
3 is true.
And 3 is true. And then 2 and 4 are false. Oh, I didn't get rid of that. There we go. Get it back. Okay. Last column. We're almost done. Right? We're going to look at 3 implies 4. It is another implication. All right.
The last 4 are true.
The last 4 are true. Okay, so actually anything with double T's is true, right? Can we fill those in first? Is that okay with everyone? Yeah. So the first one is true, true. And I think it's on the 5th one, and the 7th one, and the 8th one. All those are true, true, because they say true, true. So they're true. Anything starting with false is true. So in row 2, it starts out false. Row 3 starts out false. Row 4 starts out false. And row 6 starts out false. We have a tautology. We do. They are all true statements on this one. Make sure I got them all in there. This is a tautology, which means it is valid. And this is the equivalent of the argument that we had where it would say something like this. All cat lovers are pet lovers. JJ is a cat lover. Therefore, JJ is a pet lover. It's that kind of a statement with the if-thens. You can't see that because we don't have language with it, but it's that kind of a statement. All right. Example 3. Sounds funny. Came straight out of something else. I did not make it up. Number 3 means we have to do the whole kit and caboodle. There's words, I have to assign letters, I have to create symbols, I got to do it all. So it starts out with saying, I'll just read it all first. If I were a woman and you were my man, then I'd never stop loving you. I've stopped loving you. Therefore, I am not a woman or you are not my man. If you can make sense of it, that's fabulous. It's very wordy. Right? It sounds funny. That's kind of why I pick it, is because it sounds funny. We're just going to piece it apart. That's our goal. There are 3 separate sentences. Do you see them? Okay, that's good. The 3 separate sentences are going to be like we have here. Statement 1, statement true, we draw a line, statement 3, and then we're going to merge them all together, much like they were merged all together at the beginning of number 2. Okay? Those are the 2 pieces we haven't done yet. Whoops. There we go. We're going to create all the pieces on this one, and then we're going to do the truth table on the next slide, because there's no space for doing all. Okay, so first sentence says, if I were a woman and you were my man, then I'd never stop loving you. All right, so the first piece, if I were a woman, is P. Sound good? The second statement says, and you were my man. That's Q. That is the you were my man part. That's Q.
Just so you know, your writing is visually.
Thank you. Okay, so the individual statements. The first one is, I were a woman. The second one is, you were my man. The last one should be, yeah, and it's in a negative sense, right? So the never part itself is going to make a negation, but the stopping loving you is going to make my statement. So the piece here that says stop loving you, that's actually going to be a separate statement, and it's R. So I'm going to start with that sentence. I've got a P, I've got a Q, and I've got an R. There's 3 separate things going on. So P is the woman, and then I have an and statement with Q. And then it started out as if, so I now have these two joined with an arrow. And it says, I'd never stop loving you, which would be the negation of R. The first statement's really messy. The second one's not. The second one just says, I've stopped loving you. So what is I stopped loving you going to give us? R. So it's going to just be like the second line in those arguments that we did like on number 1. It's R. And my conclusion then is therefore, I am not a woman. So what is I am not a woman going to be? Tilde P. And then it says or. That one's the V. The V is or. Or you are not my man. Tilde Q. Okay, so this is step 1. We've assigned the letters and we've step 1 and 2, and we've created all of the structure here. So step 1 was doing the letters up here. Step 2 is assigning the structure down here. Okay? And then step 3 is putting it all together in a long statement like we had on problem number 2. So we take the first statement, which was P and Q arrow tilde R. And we join it together with an and statement with R. So all of this is the part that's above my therefore line. And I need another set of grouping symbols. You'll see usually curly braces used at this point. If you just want to use another parenthesis or something, it's fine, doesn't matter. But all of this is the premise for the conclusion, tilde P or tilde Q from the bottom. Assigning all the structure is a challenge in itself. You all okay with that? We're going to take this to the next slide, and that's where I'm going to do the truth table. All right, so we're back at the point where we were on step 2, or problem number 2, except that there's tildes in this one, right? Which makes it a little messier than the last one we did. I still have 3 statements, P, Q, and R, so I'm going to have 3 columns for those. So I have column P, Q, and R. What would you like to do next? We could do a tilde R. I want to do the P and Q first just because it comes before it. So I'd like to do the P and Q here and then do a tilde R. If you did it in the other order, it's okay. Then what? Okay, so we can label this as number 1. We can label this as number 2. And then what would the next column be? 1 arrow 2. This one you'll definitely run out of space for if you're not writing really small or doing some 1s and 2s and 3s and stuff at the top. Okay, now what? Label that 3. Okay.
Now we need to do tilde Q, right?
Not yet. We've missed a step. We have to do 3 and R. So we need to get this part of this statement at the end all joined together. So all of this is where we are. We need to have a 3 and R. And you can join numbers and letters like the statements together like that. That's not a problem. It's condensed enough so it works. Okay, so then what did you want to do, Nathan? Okay, so maybe some negations for P and negations for Q, right? We don't have columns for them yet, and they're on the other side. We're going to need them. So now would be a good time to do that. Yeah. So a tilde P column and a tilde Q column would work. You can see I'm running out of space. Might have to shift some things over here in a second. What else?
Tilde P or tilde Q.
Okay, so everything at the end now, right? So tilde P or tilde Q. It's tight.
Then it's 4
Okay, so you want me to label 4 and 5? So this one would be 5. This one would be 4 over here, right? 4, and this one's 5. Did I get them in there in the right place? I think I did. Okay, so we have 4, arrow, 5. Told you I was going to run out of space. Did. And I was still writing small. Okay. This is the whole thing. All right, we're going to do our first 3 columns, first 3 columns together. So, true, 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 false, 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 true, true, false, false, true, true, false, false, and then they oscillate. True, false, true, false, true, false, true, false. And now I'm in that habit of writing small, so now it's like, but anyway, it's okay. All right, all good? All right, row 1, what I've labeled 1, is P and Q. It's an and statement. When's an and statement true? When both are true. So that's the first one and the second one and none others, right? Everything else has at least one false on it. So the last 6 rows are all false. Now I'm doing a tilde R column. So tilde R does what? Yeah, it oscillates false, true. So false, true, false, true, false, true, false, true. Good job. And now I need to do row 1 implies row 2. All right, so the first one is definitely false because it's true implies false. And the last 6 are automatically true because it's false implies something. But the middle one right here is true too. Yes, because I have true implies true. So I have lots of true statements for that one. Okay, the next one says 3. That's the one I just created. And row R. And it's an and statement. And means I need both true. So if I have any falses on there, it's not going to work. So the first one doesn't work because the row 3 is, or column 3 is false. The second one doesn't work because column R is false. Row 3 is true. And then I have a false, true, and false, true, and false. Okay, tilde P. Yeah, so false, 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 true, 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 true. Tilde Q. False, false, true, true, false, false, true, true. We're almost done. We're so close. All right, now tilde P and tilde Q, which is now going to create column 5. I compare these with an or statement. This is the first one we've done. I think it's or today. When is an or statement true? If one or more is true. Okay, so it's only false if both are false. Yeah. So the first column, or first row, is actually false, and so is the second one, because they're both falses. But the rest are all true. True, 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 and true. And then we're doing an if-then statement with columns 4 and 5. Okay, so an if-then statement is true if it starts out false. So the first 2 are true because they start out false. How about row 3? True, because it's also true. They're all true. Okay, Buddy says they're all true. Do you guys agree?
Yes.
Yep. Good deal. All true, which means what? It is a tautology, which means what? It is valid. So this is a valid argument. So as funny sounding as it is valid the way it's written. Weird stuff. It doesn't mean it's true. It means the argument structure is valid. Yes, thank you for pointing that out. Doesn't mean it's true. It means the argument structure is valid. Okay, the last part of this is actually pretty straightforward, but you need to write a few things down. These are forms for valid arguments that you can just know by looking. It's very nice. And you don't have to memorize them because you get to use your notes on the tests and quizzes, right? So that's really good too. So the first one's called modus ponens. It says if P implies Q is true and P is true, then Q is automatically true. All right. If I'm a mom, then I'm a woman, and I come in and I say I'm a mom, then necessarily I'm a woman. That's the argument that's being made on this. Modus tollens says if P implies Q is true and tilde Q is true, right? Q is false, in other words, then it must be that the other statement is false. So again, if I come in and say, if I'm a mom, then I'm a woman, and then I come in and say, I'm not a woman, then you know for sure I'm not a mom. That's the argument structure for modus tollens. Disjunctive syllogism says if we have an or statement, and we know that the second statement's false, that's what tilde P or tilde Q, and you could do the same thing here. It isn't written, but I know that confuses people sometimes. I could also just do this. Sorry, I should say P at the bottom now. So I have two statements, and if one or the other of them are true, if we know that one of them is not true, the other one has to be. That's what this is saying. Okay? Two statements, one or the other of them is true. If I know one of them is false, then the other one has to be the true statement. You guys use this in logic all the time. I will do my homework or I will go to sleep. Well, I'm not going to sleep, therefore, I must be doing my homework. Right? We use or statements like this all the time. Reasoning by transitivity, this is actually what we saw happen on number 2. P implies Q, Q implies R, therefore P implies R. And one of the places you've seen it in math is something like this. If A is less than B and B is less than C, then A is less than C. Now, the bottom two are used all the time in our world to say that statements are valid, and they're not. So they're fallacies. The first one is fallacy of the converse. It says P implies Q, and I know Q, therefore P. Doesn't work like that. Right? So I come in again, I say, if I'm a mom, then I'm a woman, and someone says, well, I'm a woman. That does not necessarily mean they're a mom. You can't go that direction. Right? That's a fallacy. Could it be true some of the time? Yes, but that's not the point. The point is it true all the time? No. Fallacy of the inverse works very similarly. P implies Q is true. Tilde P, that is, the premise is not true. Does it necessarily mean that the conclusion is also not true? So again, if I'm a mom, then I'm a woman, and it says I'm not a mom, that does not mean I'm not a woman. It doesn't work like that. That's a fallacy. So what that means is that if we have one of those structures, we don't have to do Euler diagrams and we don't have to do truth tables. If we can fit it into one of these nice 6 boxes, one of these categories, we can make our decision very quickly. And that's what we're going to do for our last 2 examples. They'll be very quick, I promise. All right, it says, if she buys, it says to decide if it's a fallacy or a valid argument based on one of those 6 forms. So we know it's going to fit into one of the 6, okay? We just have to get the structure down. So we're going to create numbers 1 and 2 from creating like this truth table steps, right? We're going to do those 2 steps. So it says, if she buys another pair of shoes, so she buys another pair of shoes is our P statement. Her closet will overflow is her Q statement. Make sense? That's what the first statement says. It's P implies Q. It says her closet will overflow. What statement was that? Q. We do our therefore line. This says she buys another pair of shoes. So that's P. And we just match it. Which one of these 6 forms does it match? Fallacy of the converse. So this is an invalid argument. So this is invalid by fallacy of the converse. This might be your favorite thing in the whole lesson, right? It's just a matching exercise. Second one. If Carrie Woods pitches, the Cubs win. So Carrie Woods pitches is P. The Cubs win is Q. So the first statement, much like the last one, is P implies Q. This says the Cubs do not win. That's the negation of Q, right? The Cubs winning is Q. The Cubs not winning would be tilde Q. Is that okay with everyone? You do my therefore line. It says Carrie Woods does not pitch. That's tilde P. Flip back. Which one of those is it? What is it?
Fallacy of the inverse.
Is it? It's modus tollens. They're very similar looking, so be careful. It's okay. This one is actually modus tollens, right? Does it match that? Yeah. So this one would be valid. It is valid by, spell it right, modus tollens. Okay, all good? Great.